Dear students and friends, welcome to Kamadhan Arts and Science College Satyamangalam. In this lecture video, we will discuss about digital image processing introduction. This video will cover the following topics: what is digital image, what is digital image processing, and history of digital image processing. First, let us look out what is digital image. Here is the definition of digital image. A digital image is a representation of two-dimensional image as a finite set of digital values, which is called as picture elements or pixels. So when an image is said to be a digital image means it is a two-dimensional image as a finite set of digital values. An image is, if it is a digital image means it contains finite set of digital values, which is called as picture elements or pixels. Always the digital elements having the pixels. Often we can call it is a pixels. So here is the figure which illustrates the image capturing system. So generally the scene element here, which is captured by the imaging system with the help of illumination energy, source energy. With the help of source energy, we can capture the imaging system. So this is 2D plan, that is a image plan, internal image plan. This is output digitalized image. With the help of illumination energy, the scene element is captured in the imaging system. So the illumination energy has reflected on the scene element, which is captured by the imaging system. So this is 2D plan. So here in the imaging system, the image is captured and it has been converted into a digitalized image. Next, continuation of digital image. Pixel values typically represent gray levels. Pixel values of the image represent the gray levels, colors of the image, and heights of the image, etc. Remember, digitization implies that a digital image is approximation of real scene. Of course, digitization of an image is real scene of an image. So here is the diagram. So as I already said, this is normal image and it has been represented in the digital image like this. In the 2D plan, it looks like this. So here each and every point of the picture is called as pixel values, uh, that is picture elements or pixels. So which represents the intensity values, that is gray levels or intensity values of the pixels. Gray level is nothing but intensity values of the picture. So here look at the digital image. In some point the intensity level is high, and whereas in the middle part the intensity level of the image is very low, so which looks in white color, whereas in the top corner of the image looking like dark, that is dark color of the image. So next, this is real scene of an image. So here zooming part of the deer ear has captured. So here one pixel is highlighted. So like a combination of the pixel can form as the digital image. So we'll move on to the next slide. What is digital image processing? So now let us discuss what is digital image processing. So I hope you can understand digital image. So what is digital image means? Finite set of values in the image is called as digital image. So here is the definition of digital image processing: processing of image which are digital in nature by a digital computer. So processing of image on the digital computer is called as digital image processing. So why do we need to process the image means, when you want to extract an exact information from the image or picture means, of course we have to process the image. Digital image processing focuses on two major tasks. One is improvement of pictorial information for human interpretation. So of course we have to improve the pictorial information of the image. So we have to increase the quality of the image for extracting the information from the image. That is improvement of pictorial information for human interpretation. We have to improve the pictorial information for human interpretation. Why we have to improve the pictorial information of the image means initially the image is not clear, so the quality of the image is very poor by the image capturing system. So we have to improve the pictorial information of the image for human interpretation as well as machine interpretation. So next one is processing of image data for storage, transmission and representation for autonomous machine perception. So obviously we have to process the image for data storage. Generally the image consumes more data and as well as more memory space. So when you want to transfer an image from one place to another place, so you have to compress the image size so that easily you can transfer an image from one point to another point. For storing also, suppose you are having 1 GB of image, 2 GB of image means, so it is difficult to store the data, so you have to compress the image for data storage as well as transmission. And also when you want to represent the image for autonomous machine perception, so we have to process on it, so we have to process the image for this purpose, for storage, transmission and representation of autonomous machine perception. So autonomous machine perception is nothing, so in the artificial intelligence nowadays, every in all the application we are using machine learning concepts, so autonomous machine perception concept. So when an object want to be recognized by the machine means, so automatically which is need to be recognized, so machine perception also, so we have to process the image. We'll move on to the next slide. What is digital? This is the continuation of digital image processing again. The continuum from image processing to computer vision can be broken up into low level, mid level, high level process. It has been classified into three levels: low level, middle level, and high level process. First, let us look at what is low level process, what is low level digital image processing system. So here input is image, output is also an image. Examples: noise removal, image sharpening. So initially in the raw image there must be a lot of noise has been mixed in the image, so we have to remove all the noises from the image. Of course we have to sharpening the image for improving the quality of the image, for extracting useful information from it. So this is low level process. When we talk about the mid-level process, so here input as the image and output as the attributes. So here input as the we are feeding the input as the in the form of image. So output we are extracting some useful attributes from the image. So examples: object recognition and segmentation. Object recognition is nothing, from the image, so we are going to recognize the various object. So and also segmentation part is nothing, so when your image is large, so you have to divide we have to divide the image in the part by part, which is called as segmentation. We are dividing the image by subparts, which is called as segmentation. This is the mid level process. And then high level process. In the high level process, input as given in the form of image attributes, and after making processing the output will be in the form of understanding. So we have given the input as the attributes, and output we are getting some concepts, some understanding concept or some understanding information from the image. Examples: scene understanding and autonomous navigation. So when you are having an image and attributes, so from the image in the high level process we can understand some scene from the image, and also autonomous navigation. So this is the examples of the high level process. So image processing technique has been classified into three process: low level process, mid level process, and high level process. Next, history of digital image processing. In early 1920s, one of the first applications of digital imaging was in the newspaper industry, the Birdline Cable Picture Transmission Service. This is the picture, earlier digital image. Images were transferred by submarine cable between London and New York. This is the very first image which is transferred from London to New York through the submarine cable. Pictures were coded for cable transfer and reconstructed at the receiving end on a telegraph printer. So when you want to transfer an image from one place to another place by submarine cable, so we have to encode the image at the source side, and of course we have to reconstruct the image at the receiving end on a telegraph printer. So in earlier 1920, the very first digital image processing application is achieved in the newspaper industry. Next, mid to late 1920s, there is some improvements to the Birdland system. So in the previous earlier 1920, Birdland image capturing system has used. So mid to late 1920s, there must be some improvements to the Birdland system resulted in higher quality images. So the image quality has to be increased. So here new reproduction processes based on photographic techniques. So here the improvement of the quality image has achieved photographic techniques. So here photographic techniques has implemented to improve the quality of the images. So how it has been improved the quality of the image means in terms of increase the tones of the image. So here in earlier in earlier 1920s, there 15 tones has been used for digitizing the image, whereas in mid to late 1920s, so instead of using 15 tones, it has increased as 20 or 25 tones for improving the quality of the image. So here is the improved digital image, whereas in this image, so the tones has increased. Instead of 15 tones, it has increased some 20 to 25 tones. So the variance from this image to this image is increase of tones, that is increased number of tones in reproduced image. So here the number of tones has increased in the improved image, so for improving the quality of the image, that is in the Birdland system, when we want to increase the result in terms of quality, so here we have to improve the tones, number of tones of the image need to be increased. In 1960s, improvements in computing technology. So later in 1960s, so we have there is an improvement in computing technologies, and the onset of the space race led to surge of a work in digital image processing. So in 1960s, so this is the image, space image, a picture of the moon taken by the Ranger 7 probe minutes before landing. So 7 minutes before landing, so this image is captured in the moon. So here the various computing technology has improved to increasing the quality of the image in 1960s. In 1964, computers were used to improve the quality of the images of the moon taken by the Ranger 7 probe. So here, instead of using the various computer technology, in 1964, the various computers were used. That is, the configuration of the computers has increased to improve the quality of the image. So computers like softwares and hardwares, everything were improved. All the configurations and performance of the computers were increased to improve the quality of the images. So when compared to in 1960s, 1964, so there is a lot of technologies has came to the industry to image processing system. Such techniques were used in the space missions, including Apollo landing. So for Apollo landing space research, so they were used various computer technologies. Next, in the 1920s to today, the use of digital image processing techniques has exploded, and they are now used for all kinds of tasks in all kinds of areas. So in the 1920s to up to today, so image processing techniques and image processing systems were used in all the areas, in all the research areas. That is image enhancement and restoration, medical visualization, and law enforcement. So let us discuss one by one how an image processing system has accomplished in the image enhancement and restoration, and how image processing techniques, and how an image processing concept has used in the medical applications, and how it has used in the law enforcement. Here is the examples of image enhancement. One of the most common uses of digital image processing technique is improving the quality and remove noise and filtering, etc. So here is the example of image enhancement technique. So you are looking various images here. So here is the image. This is the X-ray image of the human chest. So here initially in the raw image, the images were not clear. Okay, so so after implementing the image enhancement technique, the image is very clear. This is raw image. This is processed image. So in the processed image, we are able to recognize all the parts of the image. So here image enhancement techniques has used. So that is, the quality of the image is improved and various noises of the image also removed. So here is the in the next image. This is the chip or motherboard part of the computer. So here various noises are improved on the image. So here we have to implement the image enhancement technique. So image enhancement technique is nothing, improving the quality and removing the noise of the image. So here various noises of the image has removed. So after processing it, so the the image is very clear. So in the image capturing system, there are a lot of noises were there. That is Gaussian noise, salt and pepper noise, gamma noise. Like that we have lot of noises. So were added in the raw image. So obviously we have to remove all the noises from the image. So here is the there must be an we need to improve the contrast of the image. So initially in the raw image, so which is not clear, so we are not able to recognize what we are having in the image. So after implementing the image enhancement technique, the image is very clear. So in the image in the processed image, so all the noises were removed, and the mm, quality of the picture also improved. So next, so how an image processing techniques has achieved in the medical research. So image processing system has playing major role in the medical applications. So here is the example of how image processing techniques has achieved in the medical industry. Take slice from MRI scan. So this is the MRI scan picture um, of canine heart, and here we are using the various filtering techniques and edge detection techniques. So boundaries between types of tissue of canine heart. Image with gray levels representing tissue density, and so here in the edges the density of a canine heart tissue has measured. So here is the example of law enforcement. For image processing techniques were used extensively by law enforcers, that is for number plate recognition for speed cameras and automated toll systems, and fingerprint recognition and enhancement of CCTV images. So here is the diagram. Pictures were shown here. So for number plate recognition and automatic toll systems, the image processing techniques were used. And here is the thumbprint identifications, fingerprint identifications. Next examples, law enforcement. That is how an image processing techniques has achieved in law enforcement. Image processing techniques are used extensively by law enforcers. Number plate recognition for speed cameras. For in the speed camera, so when you want to recognize a number plate, Yeah, definitely you can use the image processing techniques. And for automated toll system, where also the image processing systems were used. For fingerprint recognition and enhancement of CCTV images. So when you want to enhance the CCTV image, that is when you want to zoom the CCTV image, you can use the digital image processing techniques. And in most places nowadays we are using fingerprint recognition. So it is useful. It is most useful in the law enforcement. So here is the diagram. So this picture shows the number plate recognition and automatic toll systems. So this picture represents the fingerprint recognition and enhancement of CCTV images also achieved in the image processing techniques. I hope you can understand the concept of digital image processing introduction. That is, what is digital image processing, and history of digital image processing. Thanks for watching. Have a nice day. Thank you.